Assalamu alaikum wa rahmatullahi wa barakatuh. So today is our lecture 20. So in this lecture we will study the topic functions of a random variable. So sometimes a function y is equal to g of x of random variable x is another random variable so here means that one random variable just like y, which is the function of another random variable x. So in this way we can say these are the functions of a random variable. So the PMF of fy py of y can be derived from px of x and function of x. So this is how we can define functions of random variable. So one of the simple example is suppose that if a cellular company is observing the data x as the total number of megabytes sent and received, sent or received. So based on that, the telephone company charges you, means y rupees charges for utilization of x MBs of data. X MBs of data. So in this way we can say that x is sample value of random variable x, then y is sample value of random variable y. Now as y is derived from the utilization of this x, so we can say that we can say that y is a derived random variable because y came from y is obtained from another random variable. So we can call this as, because it is derived from some other random variable, so we call it as a derived random variable. So we can formally define this derived random variable as derived random variable. So each sample value of y of a derived random variable y is a mathematical function g of x of a sample value x of another random variable x, we adopt the notation y is equal to g of x to describe the relationship of the two random variables. So it's very straightforward that that y, that is a derived random variable that comes from a mathematical function g of x, means it cannot come from anywhere else. So we have to define that mathematical function for sample value of x of another random variable x, just like in the previous example we said that x is the number of data we are using, and y is the charges based on the number of based on the data we have utilized for a month or a week or whatever we have set our data plan. So y is a derived random variable because that's been derived from from another random variable x. So we have to define that mathematical function how to obtain this random variable, derived random variable y. So let's look at this example from the book, and so let me copy it from the book. So it's example 3.25. It says that a parcel shipping company offers a charging plan $1 for the first pound, $0.9 for the second pound, and so on, means 0.8 for the third pound, $0.7 for the fourth, and 0.6 for the fifth pound, which with rounding up for a fraction of a pound. For all packages between 6 and 10 pounds, means above 5 pounds up to 10 pounds, the shipper will charge $5 per package. It will not accept shipments over 10 pounds. So we cannot send any parcel which is more than 10 pounds. Find a function y is equal to g of x for the charge in centers for charge in cents for sending one package. So we have to actually drive it step by step. So let's do it. Say step 1. So we have to look for the price and the weight. So for first we write these prices and weights. So for so we have 2 cents. So remember that $1 is equal to 100 cents. So weight is say 1 pound, weight in pound. So price for that is $1 or 100 cents. Then for the second pound, the weight is so weight is now 2 pounds. So the price will be 100 for the first, and for second it is 90 cents. So total will be 190 cents. So for the third pound of the weight, so the price will be 190 for the 2 pounds, and then 80 for the third pound, which will be 270 cents. And then for the fourth pound it would be 70 cents will be added to it, and that would be 340 cents. And for the fifth pound we have 60 cents added to it, and it is 400 cents for the 5 pound. So what about the next 5, 6 to 10? It is straightforward because that is a fixed price of $5 or 500 cents. So now we have to make a function for it. So we can see that if we multiply weight into cents like this, so that is giving me good sense. So it is 2 into 95 100 sorry 100 2 into 95, so this is 100 and this is again 190, and say 3 into then to obtain 270, so it should be 90, 270, and similarly 4 it should be 85, mine is where that would be 340, and for the 5 it should be 80, it should be equal to 400. But remember one thing, we have to make some uniform function, so that if we have the x, if we put the values of x, we can directly obtain the price, which is y, and this function would be the function of x, which is the price. So we can do one small change in it, and that is if we make it like this, 1 into 100, it is straightforward, but 2 into 95 minus 5, 100 minus 5, 3 into 100 minus 10, 4 into 100 minus 15, 5 into 100 minus 20. So that is the same thing, but now we have this one term common, and we can see that this is some multiple of some number, so that could be easily obtained, or we can write in the next step. I will write it here, next step. So that would be say 1 into 100 minus some multiple of x, say x times 5. So if I do it like this, 2 into 100 minus 2 x dot 5, so that would be then so here x should be then 0, here x should be 1, and 300 minus x dot 5 for x equal to 2, and then 400 minus x dot 5, and that should be x equal to 3, and 4 into 100 minus x dot 5 into, here x should be 4. Now how we can make it more generalized, so that we could have something like this. So if we just make it like this, that if we make this one x, such that this is x and this is 100, now minus, now we have to make this 0, so that for the first one it would be, for if it is x is 1, so this would be x minus 1 is 0 into 5. So now we can see that what we have done here is, we have just made this one as x, and we call them as x minus 1. So this is, so this we call it x equal to 1, x equal to 2, x equal to 3, x equal to 4, x equal to 5, and we call it here x minus 1, x minus 1, x minus 1, x minus. So what we have done here, so then we have this x 100 minus x minus 1 into 5. So now we can verify it for, say, x equal to x equal to 1, so it would be 1 into 100 minus 1 minus 1 into 5, so that is 100. So again we can verify it for x equal to 2. 2 into 100 minus 2 minus 1, 5, which is 100 minus, which is 100 minus 5 into 2, which is 95 into 2, which is 190, and so on. We can verify it further. So we can just open this bracket to simplify it. So it would be x 100 minus 5x minus 5, minus 5, and this minus will become plus 5. So that will be x into 105 minus 5x, which is equal to 105x minus 5x square. So now we can write down this function y, which is the function of x, which is equal to 105x minus 5x square for x equal to 1, 2, 3, 4, 5, and it is 500 cents, which is fixed for x is equal to 6, 7, 8, 9 and 10. Now we have seen that how we can derive a random function of a random variable. So remember one thing, you have to start from the very basics, from step by step to derive the function. So that's why we have done it for all the values, because it was just 5 values. So even if it is a very big, so you can start from with some certain small values, and you can come up with the generalized form of this and this function, and that should be verified for certain values of x. So here we have just 5 values here, so you can verify it for x equal to 1, x equal to 2, x equal to 3 and 4, 5 for all the values. So that's actually not a big deal, that is straightforward, but it's just a step-by-step method. Now the next step is to how to obtain the next step is how to obtain the PMF of y. So once we know that what is y, so now we need to find the py of y. So for that we can say that for some important thing, that sample value of y is equal to g of x. So that could be obtained how? Perform an experiment and observe an outcome S. From S, find x, the corresponding value of random variable x. Now then observe y by calculating y is equal to g of x. So it means that for each x that belongs to the range of x, so we compute y is equal to g of x. So now if g of x transforms different values of different values of x into different values of y, which means that gx1 is not equal to gx2 and so on, for if x1 and x2 are different values, they are not the same. So then we can have py of y, PMF of y is equal to p of y is equal to g of x, which is equal to probability of x equal to x, which is p x of x. So it means that it is straightforward. The next situation is that if g of x transforms several values of x to the same y, so if g of x transforms several values of x and that gives me the same value of the y, so for that case for each y then that belongs to the range of y, we add the probabilities. Means if x has two different values and it is transforming into y and the y gives me the same single value, so we will have to add the probabilities of all the values x that belongs to the range of x, those values for which g of x is equal to y. So generally we can write it in the form of a function, or we call it here as the theorem, which is theorem 3.9. So now we can write it in generalized form. For a discrete random variable x, the PMF of y is equal to g of x is py of y, which is equal to summation of x, g of x is equal to y, px of x. So it is generic. So if x gives me the distinct values of y, so it is straightforward what we have seen here, this one. So but if x is giving me the multiple values of x give me the same values of y, so their probabilities will be simply added together, that we have seen here. Now let's look at an example from the book. So let's copy this example, let me paste it here. So it is the continuation of the previous example. It says that suppose all packages weigh 1, 2, 3 or 4 pounds with equal probability. So we have that the packages are from 1, 2, 3 or 4 pounds with equal probability. So find the PMF and expected value of y, the shipping charge for a packet. So it means that first of all we have been given the probabilities of weights, which we call it as the x, random variable x. So we can write the PMF of x, which is straightforward because it has the same probability for all the packages that weighs from 1 to 4. So x will be 1, 2, 3, 4. 0 otherwise. Now we have to find out the range of that y. For that we have derived the g of x as x into 1 0 or sorry, we will write it in the format we have done it, 105 x minus 5 x square, so which is equal to y. So we will put 1, 2, 3 and 4 for the x, and we will get the values of y. So range of y will be then simply sy will be simply by putting the values of x into this function. So for x equal to 1 it is 100, for x equal to 2 it is 190, for x equal to 3 it is 270, and for x equal to 4 it is 340. So now this is the range of this value, and we can see that for each values of x we have got a single value of y out of this function. So we are good and easy to go. So we can say that px of x will be equal to py of y with the range of y. So that can be obtained as py of y, which will be equal to px of x, which is 1 by 4, and now because we have the y, so the range will be 100, 190, 270, 340, and obviously 0 otherwise. Now it also says that find the expected value of y. So expected value of y is simple, which is we know that summation y belongs to range of y times py of y. So that would be simply, because py of y is same 1 by 4 and we are multiplying it with 100, summation with 190, summed up with 270, summed up with 340, and that will be given me the average value of 25 cents. So this is the case where we got all the values of y that are equal, that give me the distinct values of y from the function of x. Now let's look at another example. So let's look at another scenario in another example. So this is example 3.27. It says that suppose the probability model for the weight in pounds x of a package in example 3.25 is, now we have defined this px of x, we have defined this PMF of x. So periodic in figure we have seen this is 0.15 and this is 0.1. So it says that for the packages weigh from 1, 2 or 3 and 4 pounds, so the probability of that is 0.15, and packages for 5, 6, 7, 8 has the probability of 0.1 and 0 otherwise. For the pricing plan given in example 3.25, so pricing plan that was given there, gx of s was 105x minus 5x square for x equal to 1, 2, 3, 4, 5, and 500 for x equal to 6, 7, 8, 9, 10, which is, we call it as y. So for the same pricing plan, what is the PMF and expected value of y, the cost of shipping a package? So we have to find the PMF and the expected value of y. So again we have to go the same steps. We have to find the range of y, we have to find the range of y for this example. So range of y can be found easily, that for packages from being from 1, 2, 3 or 4 with the probability of 0.15, if we put here we will get some distinct values, and for those distinct values would be we can say that s of y will be, if we just put these values 1, so it is 100, if we put 2 it is 190, if we put 3 it is 270, and if we put 4 it is 340, and if we put 5 it is 400, for 6 it is 500, for 7 again it is 500, and for 8 it is 500. So for now if we look at for here it is say x equal to 1, x equal to 2, x equal to 3, x equal to 4. So for these values from x1 equal to x2, x3, 4, the probability is this, and they have the distinct values. So what it would be then, p y of y would be simply 0.15 for y is equal to 100, 190, 270, 340. And what about y is equal to 5? So its probability is 0.1 because it is just a single value 400 for x equal to 5, but these are repeating values for x equal to 6, 7 and 8. So it would be simply 0.1 for y is equal to 500. And what we have seen before, that we have to add the probabilities for this one. For 6 probability is 0.1, for 7 probability is 0.1, for 8 probability is 0.1. So it will be 0.1 plus 0.1 plus 0.1, so that will be 0.3, 0.3 for y is equal to 500, and again 0 for y, other values of y. Now we can see that it is 0.15 times 4, it is 0.6, and 0.1, 0.7 and 0.31. So it means that this probability sums up to 1. So that seems okay for right now. Now the next step is to find the expected value of y. Expected value of y will be 0.15 times y is 100 plus 190 plus 270 plus 340, and again plus 0.1 times 500, and then it is plus 0.3 times 500. So it would be then 325 cents in average, or the expected value of this one. Let's see another scenario for this same finding the PMF of the derived random variable. So let's copy it from the book here. So this is example 3.28. So it says that the amplitude V volts of a sinusoidal signal is a random variable with PMF. So we have given this PMF which is uniform distribution, and PV of V is given as 1 by 7 for V is equal to -3, -2, so -1, 0, 1, 2, 3, so otherwise. So y is the function is defined, y is equal to V square by 2. So volts denote the power of the transmitted signal. Find Py of y. So it means that y, which is the g of V, is V square by 2, and we know the range of V is simple, -3, -2, -1, 0, 1, 2, 3, That's it. Now we have to find the range of y. So simply we have to place this value here. If we put -3 here, so it will be 9 by 2, so which is 4.5, and again put 2 here, so it will be 4 by 2, which is 2. 1 by 2 is 0.5, and then for 0 it is 0. So again for 1 by 2 is 0.5, for 2 is again it is 2, and 3 for 3 it is again 4.5. So here we can see that the values are repeated. So we have to because we know that in range we do not repeat the values, and we write them in ascending order. So we will start from 0, 0.5 to 4.5. So because it is straightforward that this is a square function, so square, we know that when we take the square root of anything, so it gives me plus and minus values. So that's why we have 3 and -3, plus 2 and -2, plus 1 and -1, and obviously 0 is 0. So we have this now range of y, and obviously we know that v is equal to 2y square root, so that's why we get this plus minus. So we can now write the py of y. So we have to be careful while writing this py of y. So we have to see how many values are repeated. So 0 is repeated only once, so it means that for y is equal to 0, sorry, if we look here, for y is equal to 0, it is 1 by 7. So we can start from here, 1 by 7 for y is equal to 0. But 0.5 is repeated twice. So 0.5 is repeated twice. So we will get 2 by 7. 2 by 7 for y is equal to 0.5. And similarly for 2, it's again repeated twice, so that will be 2 by 7. So we can say that 2 will come here. And similarly for 4.5, it's again repeated twice, so it will be, probability will be again 2 by 7. So we can say this is also for 4 by 5. So that would be 0 otherwise. So remember again, once again remember that how many when we put the values of the function, say here v, so we have to count the number of times it's been repeated. So we cannot ignore any value. So any number of times they are repeated, we have to add their probabilities from the random variable, from the PMF of the random variable given, to find the probability mass function of the derived random variable. I hope you have understood all this lecture for today. So stay blessed. We will stop here. Assalamu alaikum wa rahmatullahi wa barakatuhu.